chemistry, we are going to discuss about or no more about item number 2. And item number 2 under element of construct is an item which I'm going to go through this, but basically before we start on that item, so here in items, item number 2, I said it's under element of construct. Which areas we expect, the areas we expect questions from under this item number 2. So that this item, the learner appreciates diversity and the interactions of substances, their importance in life. So the areas where we expect these items to come from, one, we expect them to come from elements. And in the elements, you need to know that their categories, their properties, that's the suitability, plus their uses and their impact in our daily life. So, you know that the elements, basically, for them, they are categorized as a metal. In elements, we find their metals. Also, you can find a category of non-metals. And metals, they are also under a category of what? We have metalloids, and even noble gases, among others. How would you find out that item deals with the element? Now, an element, for it, is made up of only one substance. Only one substance. So, because you know an element, that's a substance that cannot be split up into two or more simpler substances. So, we find out that a scenario deals with, it has only one element that within, you need to categorize it as an element. The elements can be categorized, can be a metal, can be a non-metal, it can be a metalloid, it can as well be a metals. You know that they are the ones that loses their outermost electron. Lose their outermost electron and they form cation. Non-metals, for them, they gain the outermost electron, they gain electrons, make them stable, and at the end they form what we call an ion. For metalloids, they have two properties in between a metal and a non-what? The number is the one that is said to be. So you expect items to come from what we call a. Then two, we also expect the items to come from compounds. And the compounds, how will you know that what you need to categorize them in terms of compound when the substances which are in the scenario contains two or more elements. But those two or more elements are chemically combined together. For elements, just made up of one element. Then the compound is supposed to contain two or more elements. For example, can be a carbon dioxide, can be sodium chloride, among others. And then these compounds, basically, for them, they can be categorized. You can categorize as ionic. Compound can be ionic compound. It can as well be covalent compound. So, in item number 2, expect questions or scenarios from elements. We also expect them to come from compounds. Then also, can also expect them items to come from the structures of substance. No substances adopt structures. Among the structures which are adopted by a substance can adopt those substances. They can adopt a structure which is one can be giant metallic. Can also have giant ionic. Can also have a structure which is called the giant atomic. You can also have a structure which is called the explain the category as a chemistry learner in terms of structure. The item or the scenario may require you, or you may be required to explain the structure or to explain the category in terms of what? In terms of structure. So it means that your response, what we expect, we expect your response to respond then in terms of these structures while identifying them and as explaining them. For instance, you can have you can have a substance which can adopt what we call a giant metallic metallic structure. Can also have a substance that adopts the giant ionic structure. You can also have a substance that adopts a giant atomic structure. And you can also have a substance that adopts what we call a simple molecular structure. The one that adopts a giant metallic structure, I'm just going through this very fast before we go into the item which I'm going to discuss today. But as I said that, before I go through that item, I need to first summarize out for all what is required in that item. Number what? Number two. Also the structure. It's a giant metallic structure. It means that such substances has what we call a metallic bond. The atoms in them are bonded with very many metallic metallic bonds. So since they are bonded with very many metallic bonds, they adopt what we call a giant metallic structure. Then here, the one that adopts a giant ionic structure, for them, those are the ionic compounds. And those ionic compounds, they are bonded, the ions, that ionic bond are bonded together by strong electrostatic forces of attraction. That makes them to adopt what we call a giant ionic structure. Then giant atomic, what can be also called giant covalent structure. But then the elements in in that covalent bond, but then they are bonded together by very many strong covalent bond that makes them to adopt what we call a giant atomic structure. Then simple molecular structure, some that adopt simple molecular structures, they are the ones whereby they are covalent compounds, but they are bonded with what we call, or they are bonded with what we call weak van der Waals process of attraction. That makes them adopt what we call simple molecular structure. So, in your side, you try to get examples of each of these categories which I've given you. The examples of metals, non-metals, metalloid, ionic compound, covalent, giant metallic, giant ionic, giant atomic, with also simple molecular structure. Should make sure that you get those examples with their properties. Then also we expect questions or we expect items to come from what we call trend in the periodic. Trend in the periodic. Need to explain the trend in the periodic table. Need to be explained under this trend. We need to know the variation of melting point across a period. That variation of melting point across a period in a periodic table. No, the periodic table, it has group and a period, whereby group, for them, those are the the one that are horizontal, and you determine the group of the element by looking at the outermost electron. Then the periodic table for the period, for them, those are the ones are the vertical ones, they are the one that are group, and then the horizontal one, they are the one that are said to be the period. So for the trend in the periodic table, sorry, for the period, you can look at their properties, the arrangement of those. There are some properties that are for arranging those elements periodic table. One of them, you can determine what to call the melting point. Melting point. So those melting point varies across the period. Then for group 4 in the periodic table, they have metals, metalloid, and non-what? And non-metal. Then from group 5 up to group 7, they are basically made up of non-metal. So since their category differs from metal to a non-metal, it implies that they will not have similar melting what? Melting point. So the melting point differs based on their category. And so basically that's what we need to know about the trend in the periodic. So we need to explain the melting point, the variation of the melting point as you move from left to right across the periodic. For instance, you can have elements in the period 3 and have elements in the period. Some of the elements in the period 3, as you are thinking about them, from those ones starting from group 1 up to the end, you think about all those elements and you list them down. Like here, the first element in the period 3, you have 1 in the there is there is from sodium, magnesium, aluminium, silicon, which in the group 4. Then in group 5, I know you are responding to those ones who will have phosphorus. Then from phosphorus, we come to sulfur. Yes. From sulfur, we come to chlorine. Then among others. So when you check those elements, they vary. And here we shall find out that these first 3 elements, that is sodium to aluminium, for them they are what? They are metal. Then this silicon, for it is a metal. And then those last 3, for them they are non metals. So for the metals, we say that the force which are holding them together, or the bond which held these metals together, are called the metallic. The strength holding these metals together, sodium metals together, are called the metallic bond. And we shall find out here the strength of a metallic bond, the strength of the metallic bond. The strength of the metallic bond shall find out here depends on the number of electrons, depends on the number number of electrons. The number of electrons contributed to the electronic count. So it is for to break them up, to separate them up, you need to apply a lot of energy. So therefore, such elements which are metals, they have what we call high melting points. They have high what? Melting points. Why? Because one, they are metals and are held by metallic bonds that requires a high energy to break them. Hence, they have what we call a high melting point. But the strength, but their melting points differs. How will they differ? By depending on the number of electrons contributed to the electronic cloud. So it implies that if an element contributes very many electrons in the electronic cloud, it will have a stronger metallic bond. And also, since it has a stronger metallic bond, it will have a higher melting point. So of these three elements, when you check, we say that this is in group one. Group one means that it has one electron on its outermost shell. And that one electron, which is on its outermost shell, is the one which is the contribute. Then the second one, we said magnesium, it belongs to group what? Group two. Since it belongs to group two, it implies that it has two electrons on its outermost shell. Hence, it's the one that's supposed to be contributed the electronic cloud. Then lastly, we have aluminium, which belongs to group what? Group three. It belongs to group three. And that group three, for them, meaning that it has three electrons on its outermost shell. So it's the one that should be contributed. So meaning that among these three elements, that is sodium, magnesium, and aluminium, we found that here it's aluminium that contributes very many electrons. And those elements that are formed electronic cloud, there are three electrons. So therefore, since contributes very many electrons on the electronic cloud, it implies to have a stronger metallic bond, followed by magnesium that contributes two electrons, and lastly sodium that contributes one electron. So implying that aluminium it has a high melting point, followed by magnesium, and then lastly sodium, which contributes only one electron. So these are for the metals. Why am I elaborating more? On the item which we are going to discuss, basically, it has what we call those melting points. The item which I want to discuss, it has these melting points. That's why I've taken much time on these 20 in it adopts it has silicon atoms. Silicon atoms, for them, they are held by strong or very many strong covalent bonds, making them to adopt what we call a giant atomic structure, or a giant covalent structure. Since it has very many strong covalent bonds, breaking those covalent bonds for real, they require high energy. So therefore they will have a highest melting point compared to these metals and non what? And non-metals. For the metals, there are metallic bonds. That's the metallic strength. For silicon, for them, they have what to call they have what to call very many covalent what? Covalent. The atoms are held by very many covalent covalent bonds. So they adopt what we call a giant a giant atomic or a giant covalent structure. Giant atomic or a giant covalent structure. Among these group four elements, so we find the hardest substance which is known. The hardest substance which is known, it is a diamond. It's diamond. Why is the hardest substance known? Because one of it is made up of atoms, and those atoms are bonded with very many stronger covalent bonds, making them to adopt what we call a giant atomic structure. Since they have those very many stronger covalent bonds, it requires a very high energy to melt them, to break them, to melt them. So implying that silicon has high, high melting what? Now for the last group, that's the non-metals. Before now we go and then we respond to our item. Phosphorus, sulfur, and chlorine. For them, they are non-metals. And these non-metals, for them, they exist as discrete molecules, or they exist as a more molecule. And those molecules, for them meaning that since they are molecules, that the structure which is adopted by that, they are called the simple. Yeah, just simple molecular structure. So since they have simple molecular structure, you expect them to melt at a very low temperature. So these ones for them, they are non-metals. Having which molecular structure? Simple molecular structures, whereby the atoms whereby the atoms are held by what we call the van der Waals forces of attraction, which are very what? Very weak, which are very weak. They can be overcome by low temperature. So they melt at a very low temperature. But still, as we look at for the metals, however much all these metals, the one that we looked at first, all of them they have metallic bond, and we've also observed that their strength increases with the increase in the number of electrons which are considered the electronic cloud. Now for these nanometals, also the forces holding them are called the van der Waals forces, and those van der Waals forces are very what? Very weak. But not all of them they have similar van der Waals forces. Their van der Waals forces differ. How do they differ? They differ. The magnitude of the van der Waals forces of attraction depends on molecular mass. So they exist as molecule for phosphorus, exists as B4. Then sulfur exists as S8. Chlorine exists as Cl. Molecular mass by phosphorus, and lastly sulfur. That's the sulfur which has the highest melting. So meaning that for sulfur, it will have a high magnitude of the van der Waals process of attraction, which will have a high melting point, followed by phosphorus, which has which is the next to sulfur, and then lastly chlorine. It has the lowest melting what? The lowest melting. So basically, that's the trend in the periodic table. That's what we should also know about their densities, which I will not go through all of them. Then not only talking about that trend in the periodic table, someone is supposed to be knowing all the concepts, that smaller concept. Also under item number what? Number two, should be able to know how you can calculate the volumes at STP, volumes at room temperature, the mass among the others. So basically, I may not complete it, and everything was supposed to be covered under item number what? Number two. Now let us go through the item. Let's go through the item which you are going to which you are going to do. The item, and then I will end it there. Having gone through the basically what's required in item number 2, let us check this item as an example.
n'abantu era enamba yagimanya eyingira nejafulumya. alina ebitonde biri mu mazzi, obungi bwa
The item goes, the durability of cooking utensils depends on the melting point of the material used. A certain company in Mukono, it tends to manufacture heat-resistant cooking utensils with good thermal conductivity from different materials. To guide the material selection, the research team collected data on the melting points of selected period 3 solid elements as shown in the table. So now all of you are viewing that table, the one that I was talking about. Here, this item comes from the trend in the periodic table. They need to manufacture the cooking utensils, but the cooking utensils which they be used in cooking. And then the research was carried out, and then you have some of those elements in period 3. So our table, it has elements. The elements, then it also has atomic number. Then it ends with point. So this is our table having the elements, some of the elements, and they have picked what they have selected the elements in period 3. And the first element in period 3, we saw it was what? Sodium with that symbol Na. Then magnesium, Mg. Then aluminium, A what? A. Aluminium, A. Atomic numbers are given. Sodium, the atomic number is what? 11. Magnesium, it is 12. And the aluminium, it has atomic number of what? 30. The melting point for sodium melts at 98 degrees Celsius. Then magnesium melts at 650 degrees Celsius. And then aluminium, according to what has been given, it melts at 659 degrees. So when we recall what we had just discussed before handling this item, when we recall what we have just discussed in the trend of the periodic table, what we expect aluminium to be with the highest melting what? Melting point. And then when I check these figures here, is the one with the what? With the highest melting what? Melting point. Why does it have the highest melting point? One, aluminium, first of all, it is a and that metal, we say that it is held by what we call metallic bond. And the strength of the metallic bond depends on the number of electrons contributed to the electronic cloud. So when you check sodium with atomic number 11, it has electronic configuration 2 to 8 1. And that of magnesium is what? 2 to 8 to 2. And aluminium, it is what? We are arranging those 13 electrons, which will be 2 to 8. Those outermost electrons, the last electrons there, they are the ones that are contributed. They are the ones that are contribute. So it's sodium. This has one electron to contribute only one electron. Then from why? Because the only one electron which is on this outermost shell. Magnesium contributes it to those two electrons when we are talking about the outermost one. The other that are contributed aluminium, it contributes to it. So since aluminium contributes very many electrons compared to these two, implies that it will have the highest melting point, followed by magnesium that contributes to electrons, and then lastly sodium that contributes to one electron. So we need to have contacted you when you go back to our item. So that's the table. They do not know how to analyze the data above in order to select the best material which can be used for the manufacture of equipment in consideration of environmental concerns. They have been referred to you for help. So they have come to you as a chemistry learner who knows, who have learned about trend in the periodic table. How will you guide research? They may not be knowing which type of the element to be used in making of cooking utensils. Yeah, they are provided with sodium with its magnesium with its melting point, aluminium with its melting what? Melting point. Then they need you to find out of those elements, which one will you select? Which one will you select to be used in making of those cooking utensils? So when it comes to task, categorize the substance with reason basing on the type of structure. Basing on the type of structure. Categorize the substances. Basing or categorize the substance with the reasons basing on the type of structure. Remember, we talked about the structures of substances that are adopted. Among them, I know you were there, you can respond, those structures that are adopted by substances. These are the substances you have sodium, magnesium, and aluminium. They are among the examples of substances that adopt the structures. And if you recall, we saw that here the structure that can be adopted by substances will have what we call giant metallic structure. Yeah, if you recall. Then also we have a I pause around such that you can be able also to respond. First one I've talked about giant metallic structure. We also have giant ionic structure. We also have giant atomic structure, and also have what called simple molecular structure. For giant metallic structures adopted by what? Then giant ionic structures are adopted by ionic compound. Then for giant atomic structures adopted by some covalent compounds like silicon dioxide, that's sand, you have diamond, graphite, the dioxide, water. For them, they have ammonia. They adopt what we call a simple molecule. Now, since these elements that have been given, I will say that they belong to which category? They belong to a category of metal. So, they say that categorize these elements. We are responding to our first item. That categorize those substances, which includes sodium, magnesium, and aluminium. Basing, giving reasons basing on their basing on their structure. So, meaning that since they want structure, meaning that sodium, magnesium, and what? Aluminium. For them, they are metals. And they adopt which structure? We said is called the giant metallic structure. Yeah. First of all, we said just say how would you categorize since all of them they belong to one substance, which are they belong to one category, which is metal. You may not simply there because all of them they adopt one what? One structure. They adopt one structure. So just that here, sodium, magnesium, and aluminium, they are metals. They are metals having which structure? Giant metallic structure, which adopt a giant metallic metal structure. Because you are supposed to give a reason. Because the atoms are made up of very many strong covalent bonds. Yeah? Let us respond again to this item we said here. Sodium, magnesium, and aluminium. And aluminium are metals with or which adopts a giant metallic structure because the atoms are bonded with very many strong metallic bonds. So that's how we can respond to that item basing that. Then part B. Part B. Part B. We come to part B. Part B. That we need to categorize the part B. They wanted to categorize based on given the type of structure which they adopted to understand the trend in the property of substances in the table. They want to understand the trend in the property of substance in the what? In the table. When you check the trend, the sub or the property which is there in our table, it is melting. The property is what? Melting. Melting point. That's the property which is there for this sub. So they want you to they want them to explain to them so they can be able to understand how these the variation of these melting points of these metal. And we observed that here you need to explain, you state that trend, and also you need to give the rate. So how will you give it? How will you state that here the melting increases from sodium through magnesium to how you say that trend that here the melting point increases from sodium through magnesium to aluminium across the field. And you're supposed to give the reason. Why does it increase? It increases because this is because you said here the melting point increases from sodium. You are supposed the whole name sodium, don't write any A. When you are writing, when you are responding to this item, don't put any AM or A. I remind you that has been given there. Statement, you write the whole the name for that element. Ah, there are what? There are metals. Then there are metals, the melting or the metallic strength increase. The extent that's what it increases due to the increase in the number of electrons contributed to the electronic cloud. Hence, increase in the melting point. How do you explain that trend? Let us repeat together that here the melting point increases from sodium through magnesium to aluminium because the elements are metals with which are metallic bonds and their strength increases with the increase in the number of electrons contributed to the electronic. So the number of electrons in the electronic clouds are increasing from sodium to magnesium to aluminium. Hence, an increase in the melting. So basically, that's what we should talk about under that. So we start here. One, there are metals having what? Metallic bond. Metallic bond. And their strength, we talked about their strength, the strength of the metallic bond increases with the increase in the number of electrons number of electrons contributed to the electronic cloud. So just as there are metals which are held by metallic bond. And we can even talk about the structure, adopting what we call a giant metallic structure. And their strength increases the number of electrons contributed to the electronic cloud. So since the number of electrons are increasing from sodium to magnesium to aluminium, their metallic strength, that's what increases, hence, and increases that's how you can describe that trend. Come to C. C. What is it? Okay, now we've talked about the category that there are metals. We are responding to the item with a giant metallic structure. We talked about the trend in the melting point, which we discussed before responding to this item. Then we are coming to part C. Part C. Now, the material to be selected among the substances. Now, just recall what they have placed there in our table, even in a scenario. Out of those three elements, which one will you select? With a reason. Which one will you select to be used as a cooking utensil? I will have sodium. When you apply it when you are cooking, for it melts at 90 what? 98. If you use magnesium, when you apply it in its application when you are cooking, if for it melts, remember you want to as a cooking utensil, what you use when you are cooking. When you